Hi, everyone. We're here to just take a look at how a few of these mole and particle problems might work. So if you've been reading through the lesson, this might help sort of get you going and get you on the right track as to how to set it up. So here's a question for you. How many molecules of sugar are found in a 2.47 mole sample of sugar, right? So what we want to do then is we want to think about, in order to go from moles to a number of molecules, right? A molecule is just a particle of sugar, right? So this molecule we're talking about is just that particle of sugar. We want to use our Avogadro's constant and our moles to figure that out. So let's just jot down what we know to start out with. We know that the moles of the sugar, which is a lowercase n, is 2.47. Okay, and sometimes I like to start off just by writing down what I know. I also know Avogadro's constant. It's 6.022 times 10 to the 23. And that would be particles per mole, which in this case, the particles are molecules. And I'm trying to find the number of sugar molecules. That's that capital N. That's what I'm looking for. So when we go to solve this problem, just like how we laid it out in the note, number of our sugar molecules, so our number of particles, equals the moles times Avogadro's constant. So we can take that number of particles, we can find it by multiplying 2.47 moles times our Avogadro's constant, which is 6.022 times 10 to the 23. And this is where we want to make sure we are using our calculator properly. We want to make sure we're using the scientific notation button on our calculator when we're punching in that big number for Avogadro's constant. So when we do that calculation, we're going to get 1.487 times 10 to the 24 molecules, because those are our particles of sugar. All right, so we just figured out how many molecules of sugar there are in that particular sample. We can finish it off with our therefore statement. Therefore, 2.47 moles of sugar contains 1.487 times 10 to the 24 molecules. There we go.